there's like recall and recognition. So like recall is your ability to just recall something. You asked me and I remember right now. Recognition is, well, you don't really remember, but if I like showed you a picture, you'd be like, ah, yeah, now I remember. And I was thinking like maybe we could tap into that by stimulating the brain. And there's these areas called the temporal parietal junction and the left inferior frontal gyrus, where like it seems like these networks are ways of stimulating the brain to like help you grab those memories or consolidate those memories. In a lot of medicine, and when we're treating things like, say, dementia, treating things like cognitive decline in depression, or cognitive decline in Parkinson's, or cognitive decline or cognitive impairment in brain injury, or ADHD, like attention deficit hyperactivity disorder, we often think about things like working memory. And working memory is sort of like a different way of thinking about short-term memory, which is like, how much can I hold in my brain at one time, like right now? Not what happened yesterday, what happened 5 years ago, but it's just like, what am I doing right now that I can stay focused on, is what, like, that's your working memory. And there's a lot of ways of trying to stimulate that. And working memory is a major frontal cortex cognitive faculty of things like attention, and it has a big influence on your ability to pay attention, make decisions, stay focused. Like when you're driving a vehicle, you need a lot of working memory. You need to know how fast you're going. You got to be aware of your surroundings. You have to know when to stop, when to start. Oh, there's a red light. Oh, there's a car coming this way. Oh, I'm going too fast. What's the speed limit? Like you're holding all of that in your working memory at a given time. And like those types of it's a really important cognitive faculty, and we can try to enhance that as well by stimulating the brain. And I could talk a little bit, perhaps, if you like to, about like how we stimulate the brain, or what does that actually look like? What do we mean by stimulate? But did you want to follow up on any of those points?
Now I want to learn the how.
Sure, yeah. So the how is the really fun part. Like this is the neurotechnology part. So like I have, like I said earlier, I've been doing this for 13 years now. I have a neurotechnology company. We built our own brain stimulation device. I've kind of taken this across the spectrum from research. I've participated. Now keep in mind a lot of what I'll say. I'll talk about the how, but I might use more clinical examples because a lot of my experience in the field is on clinical applications. So like how can we use these techniques to help people with mental health and neurological conditions? But you can use these techniques experimentally as well, and to just understand more fundamentals of how the brain works. So there's a lot of different versions of brain stimulation. Usually, what it involves, though, in some capacity, is introducing some sort of stimulus into the brain. So, physically, now you could say you stimulate your brain when you read. You could say you stimulate your brain when you meditate. You could say you stimulate your brain when you run and go for a run or lift weights, do exercise, play sports. These are all like stimulating brain activities. Amazing for your health, really good things to do. But what I'm talking about specifically right now is like a tool, a medical tool that allows you to stimulate the brain in a very specific region. There's many different types of brain stimulation. They both tend to introduce some stimulus, usually using a form of electricity or a form of a magnetic pulse. And I want to pause for a second because I know for a lot of people that might sound like scary. Like, why would I ever do that? This sounds terrifying, or it sounds really scary, or it sounds like something I've seen in a Hollywood movie where they stimulate your brain and it's like torture, and it's not, it's really isn't that. And we actually do a lot in our field to try to combat that stigma. Like Hollywood has done us a bit of a disservice. It makes for good television, but things like electroconvulsive therapy, which you might have seen in like One Flew Over the Cuckoo's Nest, or a popular TV show on HBO, the HBO's The Penguin, which is like part of the Batman series. They do a ECT as like a torture to try to like control people. It's not that. And ECT is actually a really effective therapy for a lot of people. And so is most brain stimulation. It's really not something to be scared of. It's a very normal medical tool. And one way of thinking about that is, one thing we've all definitely heard of is stimulation for the heart, right? If you have a heart attack, what do? We stimulate the heart with a defibrillator. That's electricity going into your heart. It's the exact same idea. Like if you had a heart attack, you want some, well, not everybody needs a defibrillator. Some people need CPR or whatever, but if you needed a stimulation of the heart to help your heart, That's something that you probably want done, and it seems less scary as it's less stigmatized. The same is true. Certain parts of your brain can like deactivate or go offline, and we can just stimulate them very specifically, and it's not as intense as like a defibrillator. So we can measure and probe different signals in the brain, and we can see when a signal is either like deactivated or it's abnormal. Like just like we have rhythms, everyone also to use the heart example, because I feel like everybody, it's pretty common knowledge that the heart has a rhythm. It has a beat, like you can feel your pulse and you can say, okay, this is my pulse, this is my heart rate, and it has a certain beat, and it tends to beat a certain number of times per second. And you know that when you do different activities, your heartbeat goes up or your heart rate goes up, and um, there's a rhythm to that. What a lot of people perhaps don't know is that our brain also has a beat and a rhythm. Our brain has rhythmic cycles, and different areas of the brain operate at different rhythms and different cycles, and we can measure when those rhythms or cycles become abnormal. If I put a sensor on your heart, an EKG, an electrocardiogram, and I measure and I see abnormal signals on your heart, we call that an arrhythmia. An arrhythmia meaning it's arrhythmic. It's not in the rhythm you want it to be. And that can mean you're having a heart attack, which means your heart is sick. So if I measure your brain activity and I sense arrhythmias in your brain activity, that means that that part of your brain might be sick. And it can be a very specific part. And by sick, I mean it's acting abnormally. It's not acting the way that a healthy brain would be acting. And that leads to a lot of mental health and neurological conditions. So a lot of these conditions people experience, whether it's, diminished cognition or feeling extremely depressed or feeling extremely anxious or being obsessed, if you have like obsessive compulsive disorder, post-traumatic stress disorder, where you ruminate in fears and you have nightmares, that is because some area of the brain is either too active or maybe it's not active enough. So sometimes the area is deactivated, sometimes that area is too activated, and we want to either turn it down or we want to turn it up. And we can do that by introducing these electrical pulses or these magnetic pulses into the brain. And most of what I do personally, my lab does a little bit of everything. We do what's called non-invasive brain stimulation, which means it doesn't require surgery. It doesn't require anesthetics. Like you can do it in a room. I could be stimulated right now while I'm talking to you. Like it's very kind of low key. It's not an extreme thing. We could do it in any office. I could set it up in any doctor's office. We apply the current, and it's really straightforward. There are more invasive versions of brain stimulation for more extreme cases where you do a brain surgery. You would implant an electrode. This is more common for like diseases like Parkinson's, for example. So there's neurological diseases. Parkinson's is a neurological disease. There's psychiatric disease, which is like depression, obsessive compulsive disorder, PTSD, other neurological diseases, things like multiple sclerosis, epilepsy. The kind of difference there, and I'm kind of giving a broad picture to answer this whole question, and hopefully this is still helpful. Like the big difference is, with neurological conditions, there tends to be an exact area of the brain that you can point to and say that is exactly what's wrong. It's this one area had this one problem, or this exact mechanism is really well defined. And that's what we would call like a neurological disease. With a mental health disease or a psychiatric disease, it tends to be a little less well defined in terms of like it's hard to point to one region and say that's where depression is, or this exact area is where OCD lives. Now, I work in the field called neuropsychiatry, which is actually branching neuroscience, psychiatry, neurology, and bringing them together, which is largely operating under the belief that most psychiatric conditions actually do have a neurological component to them. It's just harder to know what that is, uh, meaning the science is a little bit behind. It was easier to find these neurological conditions and define them neurologically, but what was previously thought of as a disease of the mind, which was kind of like a psychiatric disease, a disease of the mind, and neurological was like a disease of the brain. What we're realizing now is that there actually are neurological manifestations of psychiatric disease. They're a little bit more distributed though, and they're defined. usually by connections between regions and full networks and circuits in the brain, as opposed to like a specific region. And depending on what the condition is, depends on what type of brain stimulation you use. So there is things like deep brain stimulation, which requires a surgery. You would implant an electrode for Parkinson's, as an example. We know that Parkinson's is largely affected by a degeneration of an area of the brain called the substantia nigra, which produces dopamine neurotransmitters. And that is what leads to some of this rigidity of movement and the tremors that you see in people with Parkinson's. And it's chronic, so it exists all the time. It's always going to be there. So if we could non-invasively stimulate the brain of somebody with Parkinson's, but we would have to do that every day, all the time, all day. So it makes more sense to implant something into their brain in order to kind of fix that region because it exists all the time, 24/7, 365. So, in order to help these people without people with Parkinson's coming to the clinic and basically living in a clinic, we can implant an electrode that stimulates that area of the brain. So even though it's degenerated, it's still going to get these pulses and it's still going to produce and have the activity that it needs, which can significantly reduce the tremors and all these things that people with Parkinson's experience. So with other forms of brain stimulation, though, we non-invasively can find the exact hub or the network that we need to stimulate. So this is something that we do every day in the lab for people who are experiencing depression, for example. And we do precision brain stimulation, which is sort of like the frontier of brain stimulation. A lot of these techniques I'm talking about have been around for 20, 40, 50, like a long time. What's advancing now, though, is our ability to isolate and define the protocol to use with personalized brain scanning. So everybody that comes to our lab gets a personalized brain scan. We use tools like MRI, like a magnetic resonance image. And an MRI is like a picture of the brain. We also use something called an fMRI, which is a functional magnetic resonance image, which is like a video of brain activity. The fMRI is tracking things like blood flow and oxygen, so we can like see brain activity. And we use things like EEG or electroencephalography, which tracks electrical properties of the brain, wearing it's like a shower cap with a bunch of sensors on it. It's kind of like the sensors you'd put on your heart for an EKG, but we put them on the head. And using all these different tools, we can test and find out if there's certain areas of people's brains that are acting abnormally. And then we can use a specific personalized brain stimulation protocol for that person to tweak or modify that brain activity in the healthy direction.